Hello, fourth grade. Welcome back to another episode of Bath Math. We are starting a brand new unit all about fractions, and we're going to break it up into probably the next 5 or 6 weeks. Today we'll be focusing on, or this week we'll be focusing on unit fractions. Next week we'll be talking about equivalence, but I will break it down little by little. We'll talk about vocabulary. We'll talk about what a unit fraction is, and then we'll do some practice problems, and then you'll have some activities in Blend to do. So please let me know if you need any help after this episode, and feel free to watch this episode multiple times. But you got this, it'll be great. And yeah, let's get to it. These are the essential questions and sentence stems for the week. Pause the video to read over them, but they are also available on your Math Blend page. Here is the vocabulary for the week. Feel free to pause the video to read over the words and see if there are any you may not know. Okay, so let's talk about unit fractions. This is a definition. A unit fraction or unit fractions are one part of a whole that has been divided into equal parts. The numerator is always 1, okay? So a unit fraction is going to have 1 over some kind of number. For right now, I just put the letter B because it could be 1 over 2, 1 over 3, 1 over 8. The unit fraction, the number at the bottom might be different, but just to reiterate maybe something you've learned in previous grade levels, the top number of a fraction is always called the numerator. The bottom part of a fraction is always called the denominator. And so when the numerator is 1, it is a unit fraction, okay? And I'll show you in a bit what I mean, and we'll talk about what it would be like to add several unit fractions, as well as what unit fraction is that coming out of, what whole number is that. So let's jump into that. But hopefully this part alone, just the vocabulary, helps and makes sense for your work for this week, okay? Okay, so here's an example of a unit fraction. My numerator is 1, the denominator is 2. This fraction would be half, right? 1 out of 2 parts. As you can see a drawing here, this would be half. The shaded part, it's showing me this unit fraction. There is 1 out of 2 parts. Each one is 1/2, 1/2, 1/2, right? Because there's 2 parts. What's the whole, right, of that drawing, of this fraction? Same thing here. This would be half. This would be half. It's 1 part out of 2 pieces. Right? Same thing here. This fish is 1/2. It's shaded in. This one isn't. Depending on what the question would be, that's what you would respond. Here we have 2 parts to get to the whole number of 1. So this side is 1/2. This side is 1/2. Right? So these are different ways that you can represent the same fraction. This equals this. All of these equal the same thing, just represented in different ways. Let me show you another one. Okay, so you could do this with 1/3, 1/4, 1/5. I jumped to 1/6 just to kind of show you a big difference or a big jump. But same thing, these are represented the way you say it, 1/6. The numerator is 1, the denominator is 6. Here's a representation. Each one of these rectangles would be 1/6. There's 1/6 of these shaded. There are 5/6 not shaded, right? Same thing over here, 1/6 are shaded, 5/6 are not shaded, because there are 6 parts total. Each one the numerator is showing you each part of it, right? The denominator is telling you how many pieces there are total out of 1 box, right? This whole is 1 box. The parts are 1 out of 6 parts. So same thing here, same thing here. We have 1 out of 6 fishes shaded, 5 out of 6 fishes are not shaded. I have 1 out of 6 jumps, right? I still need 5 out of 6 more jumps to go. So each one of these would be 1/6 to get to 1. Okay, so this is a unit fraction. Same thing with the 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, keep going. As long as it has a 1 above, it could even be 1/11. It would have 11 parts. One of those 11 is shaded, right? Or a fish or a part of it. So hopefully you get the point of a unit fraction. It's just a unit, it's a fraction showing you of a whole piece, okay? Let's do a little bit more practice. Okay, I want to take a moment to also describe or give you the definition of a proper versus an improper fraction. This is going to be super helpful moving forward with the next 6 weeks in terms of fractions. So knowing this, memorizing this would be key. A proper fraction is when the numerator, the number on top, is less than the denominator, the number on the bottom. So if this number is less than the number on the bottom, it is a proper fraction, okay? If the number, just by switching them, if the numerator is more than the denominator, it is an improper fraction. So the 8 being on top being bigger than 6, which is on the bottom, if that is the case with any fraction that you have, it is an improper fraction, okay? On the next clip, I'll show you how these would be broken up or drawn out visually, but I just want you to know that this is super important for the next couple of weeks. So proper fraction, smaller number on the top. Improper fraction, bigger number on the top, okay? Make flashcards, write it down in your journal, find some way to just like know this, okay? But let me show you what that would look like visually. Here are the same fractions, now represented visually. I want you to see the difference between the proper fraction and the improper fraction. Let's ignore the improper fraction for now. Proper fraction, numerator is smaller, 6/8. Visually, I have 6/8. That would mean that I added 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 6 times because the number on top is 6. If I add 1 plus 1 plus 1 plus 1 plus 1 plus 1, I have 6, right? You'd never add up the denominators. The denominator stays the same in a fraction when you're adding them up. What does add up is a number on top. So it is 6/8 by adding these fractions up. I'm not adding 8 plus 8 to make 16 plus 24 plus, no. This stays the same, denominator stay the same. Numerator, the top, is added up. So this is 6/8, okay? That means that this is not a whole number yet, okay? A whole number would be 8 out of 8 to make one whole piece. So let's see what that means. Here I have one whole piece that is 8 parts. I shaded 1, 2, 3, 4, 5, 6. I have 6 out of 8 shaded. If they were all shaded, it would be 8 out of 8 to make one whole piece. But that's not the case, right? So I have 6 out of 8 shaded here. There's still 2 parts left out, not there, or not shaded. Same thing here. I have 1, 2, 3, 4, 5, 6. 6 eighths. There are 8 parts, but I added 6 units of that together to get 6/8. There are still 2/8 not shaded. Same thing here, 2/8 not shaded. Okay, on a number line, I have all the way from 0 to 1 split up into 8 parts. So I have 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, right? This would be, getting at the 1 would be 8 out of 8. So if I were to just stop here, I would go 1, 2, that's 2/8. If I go 1, 2, 3, that's 3/8, right? 1, 2, 3, 4, that's 4/8. 1, 2, 3, 4, 5, 5/8, and here 6/8. So to represent 6/8, I would jump 6 times. 1, 2, 3, 4, 5, 6. Proper fraction. It's not passing the whole number yet. It's right below, or it's below it, okay? This number is smaller than the whole piece that you need, okay? Improper fraction is a little bit more than the whole number. So what does that mean? I have now 6 parts. I have divided my pie or the square into 6 parts, but I have gone over. right? So here, 8 out of 6, meaning 1, 6 plus 1, 6 plus 1 plus 6, all the way 8 times, because I added 1, 2, 3, 4, 5, 6, 7, 8 ones to get 8 out of 6 parts. But visually, this whole circle was shaded in. I shaded in 1, 2, 3, 4, 5, 6 because it told me there were only 6 parts in a whole. So this circle is 6 out of 6, but I have 8 out of 6, so I need another circle to represent that. So I have 6 out of 6, and this circle has 2 out of 6. I could add these equations together and I would get 8, 6. Okay, a whole pie, right? That's one pie, had 6 parts. I gave out 6 parts of that pie to 6 friends, right? I needed another pizza or another pie to divvy up into 6 parts because I still needed 2 more people to share with. That made that adding all those pieces that were eaten together, that's 8 out of the 6 parts that you could get out of a pizza or a pie. Okay, same thing here. Here I have 1, 2, 3, 4, 5, 6. So I have 6 out of 6 shaded here. And here I have 2 out of 6 shaded. So altogether, I have shaded 8 out of 6. On a number line, to get to one whole was 6 out of 6. So I have divided 0 to 1. I'm missing my 0. 0 to 1 has 6 parts. So 1, 2, 3, 4, 5, 6. Okay, I have 6 out of 6. I still need 2 more because it's 8 out of 6. So I go past the whole number, 1, 2. This would be 8 out of 6. It's an improper fraction because it's more. The numerator is larger, it has more than what it can offer, right? You're having to get more from somewhere else. So feel free to rewind and watch this again, but hopefully it helps and it clicks to know the difference between proper and improper fraction. It'll help you moving forward. And just knowing that you can add the numerators up, you're not changing the denominators is key as well. But yeah, let's do some more. Okay, let's do a little bit of practice with unit fractions and labeling them as proper or improper before we move on. Here are 4 different problems that you might see or get. These are all unit fractions: 1/4, 1/8, 1/12, 1/5. They're all parts of something, right? So let's add these up, adding up the numerators, the top number, and see what we get and identify it as proper or improper. So I have 1, 2, 3, 4, 5. Okay, so my answer here would be 5/4. Is that proper or improper? Improper, right? The numerator is more than the denominator. It is passing a whole number, right? Because a whole number would be 4 out of 4 and it went 1 above. So now we have 5/4. It is an improper fraction. Okay, hopefully you answered that. If not, that's okay. We're just practicing. The next one, 1/8 plus 1/8 plus 1/8. I'm adding the numerator, the top number, not the denominator. Here, this would equal out to, I have 1, 2, 3. So this would be 3/8. Is it proper or improper? This is a proper fraction because the numerator is smaller than the denominator, meaning we are not at a whole number yet. So if I were to draw this out on a pie, I've only shaded in 1, 2, 3. I'm still missing more of the pie to shade in, right? I would need to add more to make it an improper fraction or go over that. But right now it's a proper fraction, okay? Let's do the next one. 1/12, added several times. Let's see how many. 1, 2, 3, 4, 5, 6. This would give me 6/12. Proper or improper fraction? This is also a proper fraction, similar to this one. If I had a pie with 12 pieces, I don't know how to draw that right now. I would have to keep going. You would only shade in, let's say, 6 of them, right? Because that's how many it tells you to. It still doesn't add up to be a whole number yet. That would have to be 12 out of 12 to make it one whole thing. And right now it looks like we only have half, right? 12 divided by 6 is 2, so that's just half of the thing. We'll get into equivalency next week, but just to kind of like let you know what that would be, 6/12 is the same as 1/2. And we'll get into that later, but just want you to know that that's coming, okay? Let's do the last one. 1/5 added up several times. Let's see how many. 1, 2, 3, 4, 5, 6, 7. This is 7/5. Is that proper or improper? It's an improper fraction. The numerator, is more than the denominator. If I were to represent this in circles as well, it would fill in a whole one, and I would have to take 2 more of that next one, right? So hopefully this is making sense, and you're able to kind of see and identify if they're improper or proper fractions. Let me show you something else. Okay, I'm adding one more thing to the vocabulary list here. You already know what a proper fraction is, right? We have a proper fraction where the numerator is smaller than the denominator, and it's represented by 2 6 out of 6 pieces of pizza, 2 6 out of maybe, I don't know, whatever that could be. Think of an example, sticks of gum, and then 2 6, right? So 2 6 is way lower than a whole number. We need how many more to get to 1? 6 out of 6 is 1, so I would need 4 6 left. 1, 2, 3, 4, right? Okay. Improper fraction, we went past the 1 mark. We filled up a whole pizza already, and we took 2 more slices. We ate the whole packet of gum. We needed 2 more slices. We passed the 1. We did 1, 2, 3, 4, 5, 6. That's 6 out of 6, and needed 2 more, and that made us 8 6. Here's the other part. A mixed fraction, 1 whole and 2 6. I have 1 whole number and 2 6, the proper fraction right next to it. It's called a mixed fraction. You are mixing something. You're mixing the way that it looks. So I have a proper fraction next to a whole number. But this would equal 6 out of 6 plus 2 6 more, right? This would equal, on the other side, that's where that 8 came from, 8 6. So actually, this mixed fraction is the same as 8 6. I'm saying the exact same thing. It's represented the exact same way. If I were to draw this mixed fraction out, it would look like these circles. It would look like these squares. It would look like this number line. I went past the 1. I have a whole number already, and I have 2 more out of 6. So right here would be 1 and 2 6. Look at that. I have 6 out of 6 from the 1 plus the 2 6 more. If I'm adding up the numerators only, 6 plus 2 equals 8. It's 8 over 6. That is an improper fraction, or I can represent it as a mixed fraction and say it's 1 and 2 6. Next week, we'll get into equivalency, which means how do you tell if the fractions are equal or not? These two representations are equal, and it's just making sense visually why that is, right? I have 8 over 6. That means I went past the 6 already. How many? 2 more. So I have 6 over 6, that's equals 1, and then 2 more out of 6 next to it, okay? So that is a mixed fraction. I just wanted to make sure I went over that in case any of your tasks this week have or ask you to represent that or see what's equal. But drawing, I find that it's helpful to make sense of the unit fractions or whatever fraction it's giving you. Just make sense of it and draw it out, right? If you have 6 parts, if it tells you 4 6, then you're drawing 4, you're shading in 4 out of the 6 total. If you have 7 6, then you're drawing all 6 plus 1 more on another similar picture. So I had drawn the first circle and just did 6, and I was like, I need 2 more. I need to make sure that the next circle has 6 parts as well. So just something to think about, something to kind of mull over, but this is definitely something that'll help you in the next couple of weeks in talking about fractions. So please be sure to be rewinding in case you need to re-watch anything, or ask me questions during our Zoom calls, okay? These are some examples of mixed fractions, 1 and 1/2, or 1/2, 3 and 2/3, 10 and 6/7, 5 and 2/5, 6 and 11/12. I would challenge yourself to write these in your math journal. Just put them one underneath the other on one page. and see if you can make a visual representation of this. So I can help you with the first one, meaning I have a whole number already. I can shade that in. 1 is done. And then 1 out of 2, so a half. So visually represented, I did 1 and 1/2, right? So how could you visually represent these 4 fractions, whether it's drawing circles or drawing rectangles or putting it on a number line, or adding it up with small unit fractions. So yeah, see if you can do that, and we'll talk about it on our Zoom call. But this would be good practice in general, just to get an understanding of how these come about. I would also push you to see if you could do a, what do you call it? An improper fraction. Can you change this into an improper fraction? So I gave you the visual representation. 1 and 1/2 would be the same as 3 over 2. That would be the same. And so these are just challenges. If you don't get it, that's okay. But again, why would that be, right? So 2 over 2 equal to 1, and then plus 1 more. So this would equal me adding 2 over 2 plus 1 over 2. The denominator stayed the same. The numerator added up. That gave me 3 over 2, but I changed that into a mixed fraction to make 1 and 1/2. So again, small challenges. These are just 4 more examples that you can try on your own in your math journal. So I definitely push you to do that today. It's Monday. And as practice before you jump into the tasks for the week, okay? And see if maybe your siblings or your parents or anybody at home can do this. I bet that they don't remember how to do this either. So we're all learning, and we'll get there. No big deal. It's just practice, but that's what we need to do. We need to practice, practice, practice. And with that, we'll get better. And it'll make sense, and it'll click, and it'll be good. So don't give up on the first try. And it's fun. Fractions are fun just by drawing them visually. It's simple math. You can do it. I'm not worried. So yeah, with that, open up your notebook and get started. Thank you for watching another episode of Bath Math. Hopefully it makes sense. If not, feel free to go back and watch it again, or ask me any questions or concerns that you have in our time through Zoom. But yeah, I will see you later this week, and let's have an awesome week together. Love y'all. Bye.